We want to enable a positive feedback loop for hardware development. We think that the only way to do that is to bring manufacturability back to mechanical design and to bring reality back to mechanical design. You have folks coming out of mechanical engineering degrees out of school who have never actually been to a shop floor, who have never actually built anything with their hands. We think we're going to bring reality and manufacturability and all the information that's living on the shop floor, contextualize it, and bring all of that back into the mechanical design process. We really just want to tighten the feedback loop between these two worlds of design and build, so really smart people can iterate a lot faster and build a lot better instead of reinventing the wheel every time.
Hello, I'm Justin Fortier. Welcome to Manufacturing Excellence, a podcast by Seraph focused on interviewing people helping push industrial businesses forward. Today, my guest is Fil Aronshtein, the co-founder and CEO of the startup Dirac. Dirac is a company that helps engineers ship and industrialize faster. Their first software tool, BuildOS, can process a CAD file through their geometry engine and automate 80% of the tasks required to create work instructions. This leaves the remaining 20% for the engineers to apply their specialized and tribal knowledge to refine the output to perfection. One of the reasons why I wanted to have Fil on is because I think that there's still a massive opportunity for software to help manufacturers become more efficient and also get more done. Most of the time, this is not going to be by replacing humans, but allowing them to do much more work effectively and focus on ways to drive improvement, whether that's being able to get a product out much faster or do so at a lower cost, ideally both. Whether you want to call it AI or machine learning, there's a tremendous amount of value to be unlocked by taking knowledge and codifying it into an automated system. And now that there's an abundance of software, libraries, and even AI tools that are able to help get some of this work done faster, there's a big opportunity for manufacturers to take a look at their own processes and systems and think, what can I do in the next 6 months? How can I ease that labor constraint? And how can I use software to close the skills gap? Whether that's helping deliver a training experience that levels up people faster by providing real-time suggestions, or finding ways to take the tasks of your best people, identify what's weighing them down, and accelerate that through automation. So hopefully Fil excites you and inspires you to take a look at your own business. If you want to learn more about his company, Dirac, you can find it at diracinc.com. And so without further ado, here's my interview with Fil Aronshtein.
All right, awesome. Thanks for joining me today, Fil. It would be great if you could talk about how you first encountered the problem that you're solving at Dirac, and then we can talk about how you're solving it.
Yeah, so I got my start at Northrop Grumman, spent a little bit of time there, not a huge amount of time. My background is actually originally in electrical engineering and robotics. When I started over at Northrop, I got the whole TS clearance thing, worked on a couple of cool radar projects. When they ran out of electrical engineering work for me to do, it was kind of a slow summer. Got to do a little bit of mechanical engineering work. When they ran out of work for me to do on that front, got to do a little bit of technician work. So did a little bit of assembly, did a little bit of test, and it was really awesome to actually get to go to the shop floor and actually do some of that work. But I was really baffled by how archaic all the infrastructure was on the shop floor. Really, it's crazy to me that the most advanced companies on the planet on the engineering side of things, other examples being like SpaceX, Tesla, et cetera, had crazy advanced tools on the engineering side, but on the manufacturing side of things, completely backwards and archaic. Still using PowerPoints and screenshots and pieces of paper to know how to do various assembly sequences. And it was baffling to me. So at the time, my best friend from college, Peter, he's not my co-founder, CTO, we had been talking about this book series that we'd been reading. Peter was working on software over at Amazon at the time. This book series that we were reading is called the Foundation series. You ever heard of it?
Yeah. Apple just did a make of them. I think some people were disappointed, but
I have some strong opinions about the Foundation series. I'm a purist. If your TV adaptation does not go line for line with the book, I get upset. So I was really hoping for an entirely 100% faithful adaptation, but they kind of just took it completely in a different direction, which if you had never read the books, totally fine. Yeah. Great show, but if you had read the books first and you were like, yes, 50 years later, finally they're making a show, it's just not faithful. So I have my own strong opinions. But anyway, Peter and I had both been reading the Foundation series by Isaac Asimov, and we had been talking about how if you plot a data point here and a data point in the Foundation universe, 25,000 years in the future, where humanity is interplanetary, intergalactic. Here's where we are now. Here's where we want to be. How do we get there, right? Because I was telling Peter about how archaic all the infrastructure was on the manufacturing side of things and how we are just not anywhere near where we need to be. And so we'd been talking about that. I've been talking about my experience. We had talked about, so Peter and I both got our degrees in electrical engineering and robotics together. We spent a lot of time together. And we had been talking about how we might be able to bring robotics and automation to the manufacturing side of things. We looked at automotive, and obviously automotive is vastly more advanced than the manufacturing side of things in terms of mass production versus on the aerospace side of things, right? You look at aerospace production, it's still very artisanal. It's still very one of one. At Boeing, you have every plane that they pump out is, entirely a one of one in that it has its own unique set of work instructions. There's very, very little mass production on the assembly side in aerospace. And so we talked about how can we bring automotive level of automation to the aerospace industry. And so initially, we actually set out to build our own sort of like aerospace factory of the future. We wanted to bring robotic assembly to aerospace systems. And so we set out to build this factory. We had, for several months, built out a bunch of simulations of this generalized robotic assembly system that would live at the heart of this factory that we would try to build. And so we wanted to generalize all the assembly because, we wanted to sort of be this like contract manufacturer of the future. And so we had this initial thesis that there was this phenomena. We called it the middle volume valley of death, where if you have more than 100 units, there are too many to do by hand. Fewer than 10,000 units isn't really enough to justify automating economically, nor is it really enough to get the attention of like the massive contract manufacturers like Jabil and Flex. And so you have this like middle volume valley of death, where you have like between 100 and 10,000 units, where for the past 50 years, many aerospace companies have fallen into, where they either, run out of money and died or got rolled up and acquired. In the past 50 years, we've seen this massive consolidation in aerospace, which has resulted in what we know as the primes. So I had this thesis that said, if we take one archetype of a system, let's say we start with a drone, right? A quadcopter smaller than a cubic meter. If we take that system and we take, 10, 15 small and medium volume contracts that look very, very similar, and if we built a flexible enough robotic assembly system, we take those 10 to 15 contracts, we call it like 10 contracts in a trench coat. You take them, you bundle them, build a flexible enough assembly line, you can send them all down the same line and effectively artificially induce economies of scale. And that was the idea. If you could stage production in a way where you had enough flexibility to handle variance in different steps of the process, where each system generally looked very similar. And so we kind of imagined that to be sort of the contract manufacturer of the future. Sort of like automate the 80%, then add enough of the 20% where you can switch out different parts of your line. And then having our experience in robotics, we recognized, you would have to constantly replan all of your assembly paths for doing your various steps of your assembly, which right now, in most, if not all assembly stations, you have to manually plan each step of your assembly for all of your robotic assembly systems. This is how they do it at Toyota. This is how they do it everywhere. And so we were basically saying, like, how do we automate that? Because, if we're taking in a lot of different contracts, we don't want to constantly replan all that by hand. That's a huge headache. So we said, what if we took a CAD file and used that to generalize all of the assembly planning for this robotic assembly system? And so that's a very long way of saying how we got here today. We built out this software. We called it BuildOS. And it was supposed to be the planning system behind this generalized robotic assembly system. We still have all the ROS code written, still have it. And we went to 90 different aerospace companies. And we said, for 9 months, and we said, hey guys, contract out your assembly to us. We're just two fellas, trust us, please. And they all said, the factory seems really cool, but, let me know when you've built it already, and then we'll be a customer. And they said, also, the factory seems cool, but that software you mentioned for generalizing all that planning, that would be game-changing for us today. Because that looks a lot like these things we do called assembly work instructions. And we do that entirely manually. Like, can we have that software? And for a couple of months, we kept saying, no, it's just an internal tool. We're not selling it. We're going to build the factory. It's all about the factory. And then after a couple of months, we just kept hearing it over and over again. We decided, you know what? Maybe this is actually the right place to start. And the beginning of January, so about 9 months ago now, we decided, all right, let's put the factory down for now. Let's actually take the software and let's build it out into a full platform. And that is how we are here today. It's been a fun time ever since.
Yeah. And the platform that you've built right now, It's October 2023, and you've just released your public beta, or you're taking some people off a wait list. Where are you at?
So for a while we had an alpha version of the product. Product works, it's live. I got a couple folks using it. It's pretty cool. When we did this sort of public release, we call it a public beta release, just kind of as a hallmark of like where we have a finished cut of the product, where like we can give it to somebody and they can use it and get value out of it. And like we can sell it and there could be like an economic exchange instead of just like free trying it out just to play with it. So right now we were very, very lucky in the feedback that we got since the launch. We put up a form on our website, very hacky website. I just kind of threw it together. In the form, I expected maybe 10, 20 really good leads from it. In the first 2 days of that being live after launch, we got 110 folks who applied and submitted an application, which is awesome. Just overwhelmingly really, really cool. And the majority of them were not just, we put it up on Twitter, we put it up on LinkedIn. The majority of them were not like early stage startup folks or like Twitter people who just want to play with the cool tool. Yeah, it wasn't. It actually there were a couple and like happy to give them the software too, but overwhelming amount of them were actually folks from OEMs and CMs, which was mind-boggling. And so past week fielding all of that has just been really, really exciting. I'm talking about 10 calls a day the past 4 days, just talking to all these folks. And it's super exciting to show folks the software. I do a 30 or 45 minute call with everybody, going from, I do a full demo. I actually draft a work instruction for them during the call. I do a ball valve. So that's actually the gift that's like on the website. I actually go from uploading the CAD file to complete a work instruction. My record right now with this, I do the same file every time.
Yeah.
I become like a master of this ball valve. It's like a 30-part assembly. I could do it now in 15 minutes with our software, which like I think ordinarily, I've asked a couple folks about this. I think ordinarily for this one, it might take somebody about a week or two to do this. I can crush it in 15 minutes. So it's super fun to show people that in the demo, that I can actually just talk you through this while using our software and showing you all the features, and that it is like intuitive enough that you can just walk it through in a demo. So that's kind of the state that we're at. We're very lucky in that like the folks that we have been talking to and like demoing the software for and putting in their hands and even getting them to buy it, which is awesome. We have been getting the same feature requests. It's the same 3 or 4, which we're like 75% of the way completed with some of them. So we're very lucky that we had a good sense from our design partners around what direction to take the product. So we seem to have good signs of early product market fit, which is super exciting.
Yeah, that is super exciting. It sounds a bit like the story of Ryan Peterson at Flexport, where he had a website up and people filled out the form. One of them was like Saudi Aramco. The real people are asking for my product. Must be a pretty big need. So if you were to describe just the process for those watching on video, we'll put up a GIF or something like that. But what are the steps that people take to use your product? And then after you went through that, if you want to say where you see this going as well.
Yeah. So platform is pretty straightforward. You upload a step file. Steps in ISO standards, so like any CAD software can export it. So it makes it really easy for integrating with whatever infrastructure you currently have. Drop in a step file. There are 2 screens. There's 2 phases of this. There is the pre-processing and post-processing. When I say processing, I'm actually referring to the fact that we take your assembly file and we drop it into a physics simulator, do a ton of computational geometry and physics simulation, and figure out just from the file what order to do all the assembly in, and automatically generate all of the assembly step animations as well. We automatically generate the animations, so all the visuals and the text. And then in this first screen, pre-processing or reordering is what we call it, we grab your file tree from your CAD file, and we allow you to manipulate that. We allow you to rename stuff, because a lot of times you'll have COTS components where the name for a part is just some crazy long, in my ball valve file. It's funny, I was demoing to a guy and he was like, "Oh, did you like translate this into Dutch for me?" I was like, "I've been demoing this file for 6 months, but the bolt was called something in Dutch, which translated to threaded hexagonal bolt." And I was like, well, clearly I'm not Dutch. The guy who's doing my assembly is not Dutch. So there are a couple of cool features that we have in this pre-processing reordering screen, which will essentially allow you to take garbage in, like under the assumption that whoever CAD'd your mechanical system up is not the same person doing your assembly or doing your work instructions, and allow you to create more structure, like add more sub-assemblies that are more conducive to kind of like a manufacturing CAD, renaming parts in bulk, and then suggesting to the simulator the first run of what order it should try to do the assembly in. Because, assembly is a combinatorial optimization problem. There are a lot of really good ways to do assembly that are all correct but differ. And so we allow the user to suggest like an initial first run of what the assembly, like a good suggestion for what the assembly ordering should be. So you run that through, runs the simulator, and then you're brought to the instruction screen. So you're drafting. You can group different steps together. This is all rendered in a 3D environment. You can click and drag and rotate and see it from different angles. And you can annotate, draw on top of that. You can add text. Each step, once you get into that second screen, each step has a variety of different drop-downs and libraries. You can add notes. You can associate notes with specific parts. You can, from a couple of libraries that you and your team can build internally, you can add different torque specs. You can add different tools from a library that you can build internally. We're going to start to add industry libraries. We can just populate that with torque tables. And then we're also building out this associations page where you can, if you classify a specific component as, kind of like a lot of if-then statements, like if this is this specific type of nut, then whenever that nut comes up, populate it with this specific torque wrench and, this specific like torque spec, and have that auto-populate from you. For right now, it's you just select it from a drop-down from your internal table.
Yeah.
The cool part about the software is that it actually also works on mobile, works on your phone. I could actually, if my phone's over there, but I could actually show you right now. I could draft a work instruction on my phone, and it works with 100% fidelity relative to doing it on a computer. So you can open it up and draft, and also view these on mobile devices or on monitors. Or
that's really helpful
computers.
for actually going out to the shop floor and being able to see that. That's cool.
Exactly. So that's the native. That's sort of the native way to view the work instruction. We can click through each step, see the animation rotate around, see it at different angles, and if you wanted to, you can also export in a bunch of different ways because we want this to be as portable and integratable as possible. You could export the whole thing as a CSV and just get all the steps and all the tools in like a little spreadsheet. You can export all the animations as GIFs. You could also export the whole thing as a PDF. So get your standard paperwork instruction. And then in that page, it takes your animation, takes a screenshot of time step T equals beginning and T equals end of the animation. It's sort of like a before and after for installing that specific step. And you can add steps that aren't related to a specific part. If you had, put PPE on or inspect this specific component, you can add those steps in between. So we very, very much call this an 80-20 tool, in that we automate, 80% of all the grunt work of figuring out what order to do all the assembly, all of the animations and all that stuff. And then the remaining 10 or 20% that we don't automate, the sort of nitty-gritty, rule of thumb type of stuff, like all the tribal knowledge of, grease this or Loctite that or torque this bolt to this spec. We allow the user, the manufacturing engineer, to build semantic associations between those little rules of thumb and specific components over time. So a neat little benefit of this is being able to accumulate all that tribal knowledge in your shop and not end up losing it when folks leave.
Yeah, we've done many consolidations or line moves over time, and that's usually a multi-month process for us to just gather that tribal knowledge in order to move stuff around. It's something I hadn't appreciated when I was younger, but now when I think of structured data, I get excited because what you're talking about now, the things that usually exist in disparate Word docs, PDFs, marker on something, being able to bring that together and really have the opportunity to continue to improve rather than just having another new engineer just go through the same steps over and over. That's what gets me excited, because when manufacturing as a whole has a gap of the total number of people that need to work in it in order to hit the goals, like every manufacturer we've talked to struggles to have the right people from engineering to assembly, and being able to make a more attractive offering to engineers who look at, maybe I could go work for software, I could work for hardware. And if hardware, they're like, well, congrats. 1/4 of your year is making PDF files for people to assemble. A critical part, that's why people have to do it. But yeah, that was one reason why I was really excited to talk to you today.
Yeah, man. And actually, it's funny, the way you describe it gets right at the heart of what we're doing and why we care about this. For the past 40 years, a lot of very, very smart people have been flocking to the world of software and leaving the world of hardware. I like to say, unfortunately, since the 70s, we've forgotten how to build great things in the West, or we've slowly lost the knowledge about how to do that. And I think it's because software is both the medium and the message. You can code up a forum and use that forum to disseminate tribal knowledge about how to code up a better forum. So you have this positive feedback loop about better software begetting better software. In the world of hardware, you open up a CAD file and you're starting from scratch. And if we talk about like the direction that we want to take the company and what we care about and why, we want to enable a positive feedback loop for hardware development. We think that the only way to do that is to bring manufacturability back to mechanical design and to bring reality back to mechanical design. So if we talk about a little bit of the thesis around what we're doing and sort of like our general kind of like overarching mission, I like to talk about like the history of this. So before the 70s, before the 1970s, engineers and manufacturers were connected by one thing. That was the blueprint, classic cyanotype blue blueprint that you imagine in your head. And around the late 70s, early 80s, CAD software emerged, became ubiquitous, and all of the mechanical engineers who were normally very well integrated into production, lived on the shop floor, actually knew how things fit together in the real world. They were all relegated to the back office. Since then, have been living in front of 2D screens. And since then, unfortunately, mechanical design has been totally divorced from reality. You have folks coming out of mechanical engineering degrees out of school who have never actually been to a shop floor, who have never actually built anything with their hands. And so what ended up happening really was the blueprint was fractured into two parts: CAD software on the design side and work instructions on the build side. So, CAD software has gotten all of the attention, all of the upgrades for the past 50 years, and work instructions never have. So we are actually setting out to build the 21st century update to the work instruction, and then over time as a company, we're going to bring them closer and closer together until we reunite the blueprint. Doing that, we think we're going to bring reality and manufacturability and all the information that's living on the shop floor very fluidly, as you described before, living in a Word doc or a PDF, contextualize it, and bring all of that back into the mechanical design process. We really, really just want to tighten the feedback loop between these two worlds of design and build, so really, really smart people can iterate a lot faster and build a lot better instead of reinventing the wheel every time.
Yeah, it's definitely difficult when you have a design engineering team that has something laid out and then it gets that transition, that handover to be made, and it turns out it's much harder to make, and it's going to probably require a redesign to hit the original cost targets. That's something we've seen a few times with some of the startups hitting industrial stage, and that's a painful process. And I'm imagining a future when I saw your mock-up where they can try to run the work instruction tool, and it might say, hey, you've got a big problem here. What you're going to try to do is going to be very difficult, or there's no logical way to actually do this, or this screw you've put here that you think could be screwed in is actually going to take a very special assembly piece. So yeah, I can see the future of where your product could continue to evolve. I'm not going to make any feature requests here, but I think it's when you mentioned the engine or the physics, the way that it's evaluating the file. Was that something you had built prior to this January, or has that all been done in the last 9 months?
It was, I think we had first started building it in around October. We had, again, this was like out a planning simulator in Ross when we were doing a lot of robotics work. Mm-hmm. As we transitioned it, so not too long before that January, we had building out the robotics simulation, and we had been, I guess around January is when we started to productize it as its own thing and do that pivot from decoupling it from the robotics. But it's funny, it does have its root in robotic assembly in that a future path that we can and probably will end up taking the product, potentially like a different product line, something. A couple of robotics companies have reached out to us about doing this, is having this serve as a generalizing planning engine for robotic assembly. But yeah, I mean, I would say the useful version of it we started in January. Yeah.
Wow, that's impressive that you've cranked that out so far.
Appreciate that.
And
we got the best. The team is awesome. I don't know if I mentioned this, but our team is entire. We call ourselves the anti-software company, in that the entire team, everybody has a hardware background and is pivoted into software. My background, Peter, my co-founder's background, both in electrical engineering and robotics. Our first hire, his name's Keenan. He's awesome. He was a manufacturing engineer over at Boeing, over at their commercial airplane facility in Seattle. He was manufacturing engineer, mechanical background, manufacturing engineer for a year or two there. Then found out he had an knack for software, pivoted into software, then built software for their commercial airplane facility for the next 4 years. Similar story with one of our other engineers, Jared. He was a manufacturing engineer at Hubble Power Systems, went over to General Dynamics Electric Boat, was a senior nuclear engineer over there, so for a Virginia-class subs over there. And then he found out he had an knack for software, pivoted into that. So it's very much like the theme of everybody that we work with is having a hardware background to understand the problem and care about it. But we generally feel like pure software folks, this is a very niche problem, and pure software folks typically don't typically have the mental framework for understanding the discrepancy between simulation and reality, which is like right at the intersection of like where we are. So it's like very, very specific type of person who knows and cares about this problem. So we've been able to move fast because we spent a long time trying to get like very, very specific types of people.
Yeah, I was encouraged by your site looking at the team page and even the language that you wrote, because it's not the first efficiency through software startup I've seen. And a lot of them, I think, have burned out some of the folks I work with in manufacturing because they just didn't ever have that true context that you've built. So it's really encouraging to see that type of background. And maybe you can mention a bit why you named the company and where that came from.
Yeah, so the company's called Dirac. We named it after the physicist responsible for the discovery/invention of quantum mechanics. There were 3 guys who won the Nobel Prize for quantum mechanics / were affiliated with the discovery of quantum mechanics: Schrödinger, Heisenberg, and Dirac. Everybody knows Schrödinger and Heisenberg. Nobody knows Dirac. The only people who know who Dirac is are electrical engineers and physicists. And if you do know him, then you know his name is written all over half of the things in your field. So very similar to the type of problem that we're solving, engineers love to build software for other engineers. Nobody really builds software for technicians or manufacturing folks. And that's what we're doing. So very similar to how Dirac, very, very prominent figure in a very niche space, really in the context of human history. And then similar to the problem of assembly work instructions and manufacturability, there are 2 types of people I like to say there are in this world: people who know what work instructions are and people who don't. Most people don't know what work instructions are. The IKEA assembly manual is usually my reference to explain to people what they are. It's like that, but 1,000 times more complicated. And if you don't know what work instructions are, you're like, couldn't care less. If you do know what they are, you've been plagued by them at some point. So very similar, I guess, ethos to that. Also just a really cool name.
Yeah, it is. So your focus right now, where you think this solution will have the most applicability, is that aerospace and defense manufacturing for the next time, or is it, have you seen interest or it applying in multiple areas?
Yeah, we've seen this sort of across the gamut. We are explicitly very good at mechanical assembly. If you look at like composite layup, it's something we've talked about with a couple of different prospective customers, but software is not the best for composite layup. So the folks that we've had a lot of interest for and are currently working with are like, tier 1 through 3 automotive OEMs, same with tier 1 through 3 aerospace OEMs, and contract manufacturers. So people who do pumps, vacuums, various basically my proxy is if it has bolts, that's a good customer.
Yeah.
So if the concept of subassembly is native to what you do, that is a very good use case generally. So discrete mechanical assembly, so like automotive, aerospace, defense, various electronics manufacturers. So we're working with one really, really awesome company out of San Diego. They have 1,000 different SKUs, and they're an incredible company. That's like one good example. Those are 3 areas, but we've seen interest from a lot of other subsystems or OEMs of various subassemblies that you would see pop up in aerospace and automotive.
Yeah, awesome. Well, I think that we're going to wrap there. This was awesome. Thanks for making time, and look forward to seeing your company grow and hopefully save manufacturing engineers and many, many decades over the next couple of years.
That's what we're looking forward to. Thank you for having me. It was
awesome.
really fun.
To learn more about us, you can visit us at seraph.com or on LinkedIn at Seraph Consulting. Seraph is a specialized global strategy and consulting firm that partners with business leaders to handle their most complex supply chain, operations, and manufacturing challenges. Leaders from across the globe come to us to solve their immediate problems and capture their biggest opportunities. We deliver long-term operational improvements by working with leadership teams
from the plant floor to the boardroom, enabling our clients to transform their entire manufacturing operation. If you learned something from this conversation and want to make sure that you're able to hear future episodes we have coming down the pipeline, make sure to subscribe to this wherever you listen to podcasts. Thanks for listening, and I hope to see you on a future episode.